So, what is the formula for the area of a triangle? Do you know this? Do you remember this, perhaps? Let's look at this triangle, right? We will call this side the height. This can be the base, right? We have a side that's equal to h and a side that's equal to b. We don't necessarily know this side length. The area is equal to 1/2 times the base times the height, right? B times h. 1/2 times b times h. That will give us the area inside of that triangle, right? So here's a question for you. What is the formula for the area of a triangle when the base and the height are the same size, x? So I think, yep, here we go. Look at this triangle. Now, in this one, they're different, right? H is not equal to B. In this triangle, they are equal. So, if that is the case, what would the area be equal to? Can you write a new equation using x as the side lengths? And can you use indices to write it? So take a moment. Try and write the equation for the area of this triangle, right, that has side lengths of x and x using indices. Take a moment, maybe pause the video, and then I'll show you the answer. Okay, it is the area of this triangle is equal to 1/2, right? That does not change. That is a constant, times the base times the height. Excuse me. But they are both equal to x. X times x is equal to x to the second power. So x with the index of 2, right? So we can rewrite this. Area equals 1/2 times x squared, right? Sometimes we say squared when it's a 2 up here. So as we keep going, we're going to keep talking about area and volume. Here are some formulas for the area and volume of shapes. Let's look at these. So the surface area, right? That's all of the area on the outside of a sphere. So like if this was a soccer ball or a football, all of the things you could touch on the outside is the surface area. And then the volume, that's all the space that is inside that fills this up. You could imagine like all of the air that is filling up the ball would be the volume. So for this sphere, we have a surface area of 4 pi times r squared. And this symbol, the symbol is called pi. I don't know if you know it yet, but it is a very magical symbol. We will talk about this. Right now, you just need to know that it is equal to something. We will see exactly what that is, and we'll talk about that a little more. But this is pi. It is equal to a number, but it's 4 times this number pi times r. R is the radius, so that's from the center of the sphere to the outside edge, right? And then squared, right, to the power of 2. The volume is equal to 4/3 pi times the radius, and not to 2, but to 3, the power of 3, index of 3. So 4/3 pi r to the third power, right? Let's look at the area and volume of a cube. We kind of already saw this, right? We did this in a problem earlier. The volume is equal to a to the third power, right? And if we go back, I'm going to click back really quick, right? Back. So a would be like the side length, right? And if it's a cube, all of these are the same. So a is the length of the side. Forward again, sorry about that. Um, so the volume, all the space inside of this, is equal to A, the side length, cubed, or to the third power. The surface area, right, S, when we saw this earlier too, is the side length, A, squared, or to the second power, right? That gives you one side times 6, because there's 6 sides. So, do you notice any similarities with the indices? Think about it. Write it down in your notebook, perhaps. What do you see? So let's compare. Let's look. Surface area here, right? Perhaps there's something similar to surface area here. What do you notice about the indices? Here it is 2, right? It is also 2 here. Interesting. A pattern emerges. Volume, let's look at those. 4/3 pi r cubed to the third power, right? There's a 3 here. There's also a 3 here. Interesting. So all areas have an x squared, right? In this case, the x is r squared. In this case, it's a squared. And all volumes have an x cubed, or to the third power. So in this case, it's r to the third. In this case, it's a to the third. Very interesting. You might want to write that down somewhere. All right, let's talk about negative index. So a negative index means how many times 1 is being divided by the base number. Let's look at an example. So 3 with a negative index of -3, all right? We divide 1 by 3, which is our base, and then do it 2 more times. So a total of 3 times, right? So 1 divided by 3 times 3 times 3. And these happen right before you divide. So 1 divided by 27, or 1/27th. So this is why keeping that 1 in mind is very important, right? It is 1 divided by 3 times 3 times 3. Okay, so this negative does not mean you're going to get a negative number. You won't, right? It means that it is 1 divided by instead of 1 multiplied by. Keep that in mind when you see negative indices, a negative index, right? 1 divided by your base times whatever this number is. That is how you get the correct answer for these. So we can see our base 8, right? In 2 different examples. 8 to the -2 would also be equal to 1 divided by 8 to the second index, right? Or the second power, 8 squared, which you could also think of as 1 over 8 times 1 over 8. Because in this case, you multiply the denominators, right? Or 8 to the -3 power, the -3 index, same exact thing, right? You can see here, 1 divided by 8 to the third index, the third power, would also be equal to 1/8 times 1/8 times 1/8, right? You can do that math if you'd like. Here's a question. I want you to think about this one. Write it down in your notebook as well. What is 3 with an index of 0 equal to, and why? So take a moment, think about it. Pause the video perhaps. 3 to the index of 0, 3 to the 0 power. What is it equal to and why? Give you a second. Okay. 3 with an index of 0, right? What is it equal to? Let's see, did you get it right? It's equal to 1. Yes. So why? Why is it equal to 1? How can we start with a 3 and we have a 0 and it is equal to 1? So remember again, in both of these definitions, the index means how many times 1 is being either multiplied or divided. So 1 multiplied or divided by the base number 0 times, right? That's what the 0 is equal to. So 1 divided by 3 0 times would be 1, right? You're not actually dividing it. Or 1 times 3 0 times would still be 1 because you're not actually multiplying it. So if you ever see any number with an index of 0 is equal to 1, right? Because you're not doing anything to that 1. Indices are how many times 1 is being multiplied or divided depending on whether it's positive or negative, right? We're not doing it at all, right? It says it right there. We're not doing anything to the 1, so it stays 1. I'd write this down. Okay. So, to show your amazing, complete understanding, I would like you to do the exercises that are on the worksheet. You can do these in your notebook if you would like. That's where I would like them. I'm hoping that I will be there next week so we can talk about them and keep working on this. Thank you so much for being patient with this process. I know watching a video is not quite as fun as being in person, but hopefully I will be there very soon. All right, get to work. Thanks.